So today we're going to learn about logarithmic differentiation. So first problem says we got to find dy dx using logarithmic differentiation. So the rule, one of the formula we need is to know is the derivative of ln of f of x is just simply 1 over f of x times f prime of x. So we need that rule to do logarithmic differentiation. So first I'm going to take the ln of both sides. So first step is take the ln I'm going to take the ln on both sides, so I'll put it right here. So ln of y, and then ln of this whole thing. Then let me simplify, so that let's break this into two. So this is ln of x times ln of this whole thing cubed 1 plus x squared. Okay, so we could actually simplify this even more. So first off, for the rule of log, what happens when we're really multiplying? We're really adding, right? And then we can actually simplify this. This whole thing is like 1 to 1/3, right? So let me just simplify this. ln of x times ln 1 plus x squared to the 1/3, right? Do we agree? We agree that this cube root is to the same thing as 1/3. Okay, now we can actually simplify this. So, like I said before, when you're really multiplying logs, you're really adding. So it's really just ln of x plus, and then remember the rule for logs. Whenever you have anything to the power, you put that in front of the log, the ln. So it's plus 1/3 ln 1 plus so now the second step is we gotta use implicit differentiation in respect to x. So we gotta use implicit in respect to x. So basically, whenever you take the derivative of this, but what this means in respect to x means whenever you see a y, you put a dy dx. So the derivative of ln of y is just 1 over y. And then since there's a y, you have to add that dy dx. The derivative of ln of x is just 1 over x. There's no y, so it's just 1 over x. Plus, Okay, the derivative of this, ln of 1 plus x squared is using this formula. So this one looks like ln of f of x, so you have to do the 1 over f of x times f prime of x. So remember, don't forget this 1/3, so we could put a 1/3. So the derivative ln of 1 over x squared is 1 of 1 plus x squared, and then then take the derivative of this. So derivative of 1 plus x squared is just 2x. So let me clean this up. Right, that's 2x. And then 3 times 1 plus x squared, so I'll just put 3 times 1 plus x squared. And then we got to want to find dy dx, so we're going to multiply everything by y. So if we multiply everything by y, we get dy dx, which is what we want. So let me put it here, dy dx equals y times, I'm going to put bracket, okay, so where do we find, where's our y? We got it from this equation, right? So all we got to do, so our y is this whole thing. So our final answer should be dy dx equals this whole thing plus x squared. And then we're going to put brackets 1 divided by x plus and that should be your final answer. So these logarithm aren't too hard, so you just first take the ln and then you solve for dy dx. So let's do another example. So we got to find dy dx using the logarithmic differentiation, and then we need the derivative of ln of f of x is just 1 over f of x times f prime of x. So what I'm going to do first is I'm going to rewrite it as I could rewrite this as y equals x squared minus 8 to the 1/3, and then this x, we could rewrite that as times x cubed plus 1, and that's the same thing, raise it to the 1/2. Basically, I'm putting everything on the top. So what about this one? We could put this on the top, but we would have to write it as x6 minus 7x plus 5 to the -1, right? And then the first step is take the ln of both sides, so ln. So the left side is ln of y, and then equals ln x squared minus 8 to the 1/3 times ln x cubed plus 1 to the 1/2 times ln of, I'm just putting everything in ln, so okay, now we can simplify it even more. So this, remember for the log rules, whenever you have an exponent, you put it in front of the ln, so this should be 1/3 ln and then when you're when we're really multiplying, we're really adding, because that's part of the rule of the log. So this should be 1/2 ln of x cubed plus 1 plus a -1. Don't forget the -1. Let's just call it -1. Okay, so now we got to do we got to use implicit differentiation in respect to x. So wherever there's a y, you put a dy dx. So the derivative of ln y is just 1 over y, and then you times dy dx, right? And then the derivative, so for this one, this part, 1/3 ln, derivative of that is we have to use this rule. So it's, don't forget the 1/3, so it's 1 divided by x squared minus 8 times, and then the derivative of x squared minus 8, which is 2x. This one, the derivative of this is 1/2. So it's x cubed plus 1. And then the derivative of x cubed plus 1 is 3x squared minus 1 over this whole thing, x6 minus 6x, 7x plus 5. And then the derivative of this is 6x to the 5th minus 7. And that's it. So let me clean this up. So this is 1 over y dy over dx equals 2x this is 3x squared minus 6 to the 5th minus 7 Okay, now what we have to do is we gotta multiply, we gotta get dy dx by itself, so we're gonna multiply left and right side by y. So I'm gonna use brackets, so I'm gonna multiply everything by y. So you get dy dx equals y, and then I'm gonna put a bracket, and it's gonna multiply this whole thing, right? So that's 2x 3x squared minus 8 plus 3x squared minus 6x to the 5th minus 7 x to the 6th minus 7x plus 5. Okay, so in the final answer, wherever you see our y is, we just plug in this for our y, this long thing. So our final answer should be something like this. You see our y is just this thing, I'm just plugging it in, and then you could put the bracket and it's just this whole thing. So it's 2x So this whole thing is your final answer. Okay, let's do the last one. So use logarithmic differentiation to find the derivative of the function. So what I can do is I can rewrite it as y equals x to the x 1/2. So first step, I'm going to take the ln of both sides. So ln of y So for this, let me simplify this. So remember, when you take the ln, whenever there's an exponent, you put it in front of the ln. So let me put that in front. Okay, so now I'm going to have to use implicit differentiation in respect to x. So wherever there's a y, you put a dy dx. So the derivative of ln y is just 1 over y, and then the dy dx. Okay, so we have to take the derivative of this in respect to x. So we have to use the product rule because I'm looking at it, and yeah, we have to use the product rule. So this is our f and our g. So remember, the product rule is f prime of g plus g prime of f. So that's the product rule. So f of prime is 1 over 2 square root of x. So how I got that was that's x square root of x is really saying x to the 1/2. So that's the power rule. So you have to bring down that 1/2. So it's 1/2 x, and then it's 1/2 the power exponent minus 1. So it's like saying 1/2 minus 1, which we could say 2 over 2 because it's the same thing as 1. So 1 minus 2 is -1. So it's negative 1/2. So that's how I got 1 over 2 square root of x. And then bring down the g, which is ln of x, plus, now we have to do g prime of g prime f. So here's our g, so the derivative of ln of x is just 1 over x. And then bring down the f, which is square root of x. So let me clean this up. Okay, now we gotta solve for dy dx, so I'm gonna multiply everything by y. So our dy dx is y, and then the bracket of this whole thing. So now we gotta plug in our y. So what is our y? Y is this thing. So dy over dx equals x to the square root of x So this is your final answer. So that's how you do logarithmic differentiation.